So this guy here, write down the modulus argument for this complex number w. W is 1 plus root 3i. So 1 plus root 3i w will look like that. So it's not an issue here. 1 root 3. So this guy here is pi over 3 lah. Okay, so imaginary, the real 0. So modulus w, we know that is just 1 plus root 3, just Pythagoras, not an issue, which is 2. Argument of w is just pi over 3 because it's the first quadrant. So done. Hence, write down the set of values of the positive integer n for which wn is real. So you want wn to be real. Wn to be real just means that you want the argument of wn to keep hitting the real axis, which is x-axis. Okay? So essentially, what we want, now set of positive value, this is the key word, is set of positive value n for which wn is real. Okay? This case here, what we need is argument. Okay, so we want it to be we want it to keep hitting the real axis, which is here. This is the guy we want to hit the real. So what we do is 0 plus k pi. You just keep adding 180 degrees, right? Remember, you need to extend and extend beyond the principal range, the principal of phase, to find out all the possible angles out there. Okay, so essentially that is what we're trying to do. Then this case here, what we get is actually the argument of wn should be 0 plus k pi, where k is an integer value lah. So you multiply of 180, keep flipping here and there, just keep adding. Then we know that because it doesn't mean that it's just 2k pi, because this is 0, then this is 1 pi, right? Then this is 2 pi. So 2 pi is also positive, so it means it's still okay. But just write this down first. Okay, just write this down. Then once you have this ready, what do we know? We know that argument behaves like logarithm. So we bring this n down. In this case here, n, argument w, is equals to k pi. So we know argument w was pi over 3 from the previous part, pi over 3 equals to k pi. Then if I were to cancel off, we get n equals to 3k. Now k is an integer value. So essentially n, the possible n is minus 2, minus 1, 0, 1, 2, 3, 4, and so on. Because we want n to be positive, so this is what we want. Okay, so this is what we want, right? We reject this one. Okay, so we want like this guy. So the set of value, the set of values of n, right? Set of values, solution set. The value set n is an integer value, where n is equals to 3k, and k is obviously positive integer as well. So this is a solution set. A bit too excited. So this guy is negative 3, negative 3, negative 6, multiple of 3 lah. Then 3, 6, 9, 12. Okay, I bet. It means this case it tells you that if I have w to the power of 3, w to the power of 6, w to the power of 9, I know all these are real value, understand? If I raise all these power 1 plus root 3i to the power of 3 and so on, so these are all real values. That's what they're trying to say. Any power, these are all real values. I don't know what the value, but these are all real values. Okay. So the next part is this. Now show that for all these n values, right, the wn is either 2 to the power of n or minus 2 to the power of n. Like how to do. Check already, right? Guys, this is not a very difficult question yet. It's difficult, but not the worst, okay? So and this is past year question. So I just want to you to know that the kind of question they can ask, the depth of it is something like that. Okay, so but though it's okay. Later I'll give you the March holiday revision set. Just go back and practice. Wn is either 2n or minus 2n, right? So this guy here, you want to show it. So we start with wn. Okay, so wn, we want to show it. This case here, what do? We know that wn is root 2 e I pi over 3 n. Anyone have issue with that? It's jalat, not root 2, it's 2, right? Just now was 2 here. So I use modulus rei theta rei theta, so pi over 3 is here. Okay, so this is my Wn. Then this will be 2n ei pi over 3. This is just secondary school indices. You just expand this in, not an issue. So this 2n is go, right? This 2n here is what we already found because we want to show is 2n. So in other words, right, what we need to show now is whether this is 1 or minus 1. Okay, I repeat, that is 1 or minus 1. Is it very hard to see? No, right? So that will imply that it's either 1 or minus 1. So this guy is already fixed. You have to know where you're working towards, okay? For this value of n, so in other words, this value of n, we already established n is equal to 3k. N is a multiple of 3. So there are multiples, a multitude of multiple of 3 you can use. So what you get is 2n is ei pi over 3k. Then you get 2n ei k pi. Okay? Ei k pi. Which is good because ei pi k pi, we get is 2n. We use Euler's identity. So the ei theta cosine theta plus I sine theta. Okay, so you just do that. So then this guy here will just be cosine k pi plus I sine k pi. Okay. We know that sine a multiple of 180 is always equals to the amount in my bank account is a 0. Sine 180, sine 360, sine whatever, a multiple of 180 is always 0. Alright? Cosine k pi is you toggle case. Cosine 180 degrees negative 1. Cosine 360 degrees is 1. So it toggle between 1 and negative 1. So if you have problem here, you bring out your GC, you put in sine k pi and cosine k pi. Okay, so you'll see, right, that it will toggle. So say this is cosine k pi, bracket, then this is sine k pi, bracket, second table. You see that the sine one is all 0. This is 0. I'll read this as 0. This is negative 0.0000002. So these are all zeros on the right. Okay, don't think that these are not zeros. They are all 0. The one here you see that as k is, when k is odd is negative 1, when k is even is positive 1. Okay, so what we can write down is actually this guy here is negative 2n when k is odd. Yeah, then where this 2n when k is even. Hence w, and you have w to the power of 100 and w conjugate to the power of 100. So we just start off with w conjugate minus w conjugate to the power of 100. Okay, sorry, w 100 minus w conjugate 100. Okay, in the form of ki. Now this guy here, we know from previously, if we do to power of n, and if this is even if this is let's say 3, right? This is if this is 3, we know that is when this is power of a odd number, we know that we can express in either one of these. Okay, so any one of you have any issue that I do this 99 times w, this is the largest odd number when it the largest multiple of 3. 99 is the largest, right? So this is what I will do lah. Then after which you remember your conjugate can swap places. So then you do the same thing. So what I do is w99 minus w99 here, conjugate. Okay, here. That's what I'm gonna do. So I know now that this guy is my 3k. Your n now, this is to power n, right? So it's 3k. So you know that wn, if n is a multiple of 3, So we know that Wn is either 2n or minus 2n. Okay, so but this one would you need to know that if this is k is even or odd. K is even. Then if this is k is odd. Okay, that. So what we need to do is actually just think about it. If n is equals to 99, this is 3k. K is equals to how much? 33. Sink in a bit. You get that k is 33. You know that W 99, because this is odd, is minus 299. So this guy here, what I can write down is equals to W negative 299 minus of W negative 299 conjugate. Now the conjugate is very sticky. It will stick to everything that it sees. Stick to this guy. So this guy will get minus 299 W minus of minus 299 conjugate W conjugate. The good thing about this is a conjugate of a real value is always the value itself. So minus 299, if you conjugate it, because this is a real value, it's still minus 299, right? So this case, what you get is still minus 299 W minus 299 W conjugate. Jalat. A lot of things to write. I write like that. I arrive at this guy here. Do this lah. W is you know W is 1 plus I root 3, right? Then this is minus 1 minus I root 3. We conjugate. This is a W. This is W conjugate. You add them up, that will be minus 299 2 root 3I. So this is minus 299 root 3I. Done. Is that the answer? Okay. 400. Yeah, 100. Sorry.